update, especially on the severe weather event that might occur tonight into potentially tomorrow night too. We have a marginal risk for that, so I'm gonna go over that, and then I'll go over potential snow in the Rockies and out west in the Western Mountains. But first is the severe weather event. So right now we're about 11 o'clock on Friday night, and we see this 1,005 millibar low, and we see showers and snow showers depending on elevation located with it, and that's going to produce a band of thunderstorms producing heavy rain in the middle of the night. These are going to be nocturnal storms. A band of thunderstorms is going to move through north to east, and more storms are going to fire up. There's a lot of instability. Well, not a lot of instability. There's a good amount of instability. There's a good amount of wind shear. So there will probably be some tornadoes embedded in these thunderstorms. Now, they won't be strong. It's unlikely anything above an EF2 really happens. It's probably going to be EF0s mainly, maybe some EF1s, but that's the radar. So really, from tonight onward in eastern New Mexico, far western and for western Oklahoma and for northwestern Texas, storms are going to want to fire up. So you want to be, have your alerts on. There might be some tornadoes. There is a significant, there's a marginal risk for tornadoes, I should say. But there's a risk. So anytime there's a marginal risk, don't take that lightly. That still means there's a risk. You also do have some heavy snow for the mountains here. So if you're above, I would say by 5,000 feet, you should see good accumulation. If you're above 9,000 feet, you'll see great accumulation. So that's the radar for you. Let's play one more time. You can see the thunderstorm is popping up on the radar. So, the dew points, this is like the humidity in the atmosphere. It's not too humid. Generally, dew points in like the 70s are very humid. Dew points in the 50s and 60s, it's not unhumid. It's like 13 you have right here in western New Mexico. In eastern New Mexico, it's 59, it's 60, so they can still produce thunderstorms. So just because the dew points aren't crazy doesn't mean they can't have tornadoes, for example, or severe thunderstorms. So that's dew point for you. It's not too crazy, but what is interesting is the total rainfall. This is something that I've noticed the Weather Prediction Center has put something out about it. I'll show that later. But what we have here is potential for some isolated, like 4 to 5 inches of rain and a widespread 2 to 4 inches of rain. And that could cause some serious flooding. Fortunately, this isn't like in an area affected by Helene or Milton, which is good. But this is pretty widespread because if these thunderstorms cause repeated rounds of flooding, that could be an issue. These thunderstorms, in addition to having tornadoes, can have heavy rain embedded in them. They can also have winds embedded in them. There's also a risk for hail. So there's really a risk for everything for this area, which is interesting. So you have a flooding risk, a wind risk, a hail risk, and a tornado risk. So a lot of rain is possible. And some of this precip is actually snow. Like up here into Colorado, some of this is actually snow. But for the border with Texas and New Mexico, so far northwestern New Mexico, they could see that's like 6 inches of rain. So it's a lot of rain. And that would be because of repeated rounds of thunderstorms. So that's the total precip, potential for some flooding. Hopefully there's no flooding, but you always have to be aware. So it's always a possibility. Now we look at the surface-based CAPE. In case you're wondering, because you might not have heard of this, you might think, oh, what is this? It's basically the instability in the atmosphere, and you need instability in order to fire up thunderstorms. And right now, there's not a lot of instability, but there's some instability. You get 2,166 joules per kilogram, but overall, it's not crazy. If you look at the spectrum, it can be higher. Like over here, it's higher. But it will start to fire up eventually by the time we're reaching tomorrow afternoon. And it dies down a little bit. And it fires up a bit again. And this would actually be interesting. Towards the end of the model run, this would be pretty significant. I've seen some other data that shows that southern New Mexico might have a threat for southwestern New Mexico anyway. It might have a threat for tomorrow. So it would be like tomorrow evening, because it would be around 7 o'clock. Don't quote me on that. So that would be interesting. The CAPE levels are reaching fairly high and fairly widespread. So that's quite a bit of instability. But what's interesting is that the instability kind of ebbs and flows. Here it's not too much, and then it comes back again, and then it kind of dies down. And then you can see it kind of comes back again. So that's interesting, to be honest with you. But that's the Cape levels. Sorry, it keeps moving around because Pivotal Weather is a horrible website, but it's okay. Anyway, the point is, there's decent Cape, but there isn't enough Cape to produce like crazy thunderstorms. So I only have a marginal risk. So yeah, that's the instability in the atmosphere. Definitely enough instability to produce severe storms, but not widespread. Not anything too major. Now I have wind shear. Wind shear will be abundant, which is why we have our tornado risk. You can see this is around 3 a.m., which isn't even going to be the peak of the storm. It's going to be 3Z, which is around 11 a.m. or 11 p.m. Decent wind shear, and these could fire up tornadoes. This is the wind shear is the main ingredient, sort of, that you need in tornadoes. If you have wind shear, it's basically impossible to make a tornado. Wind shear is the most important thing, so when you have a lot of it, that's key for making tornadoes. So that's one of the main reasons they have a tornado risk. But the wind shear isn't crazy; it can get all the way to 70 knots, so that's kind of unusual. And the other factors in the environment aren't great for producing strong tornadoes. And as we go, we eventually lose our wind shear, and then similar thing happens with the Cape. We get our wind shear back, which is going to prompt that other tornado threat. Not tomorrow, not today, but tomorrow or Sunday, depending on when you're watching this. And then the wind shear kind of moves on out. But it's kind of interesting, like the Capes. We get our wind shear, and then the wind shear moves out, and then we get our wind shear again, and the wind shear moves out, and then we get a little more of it actually. But for the most part, it's kind of like the Capes, the fact that it's moving in and moving out, which would be interesting. But there is definitely enough shear to cause tornadoes, but just not strong tornadoes. But you should always be aware. Like, even if you think, oh, it's just gonna be an EF0, it's not that big of a deal. Like, an EF0 could still like knock a tree down, or if you're outside in a car, theoretically, it probably can't flip your car, but it could maybe, if you're turning, it might cause an accident or something. It can cause damage. That's the point. So don't take it lightly. And also, tornadoes might not even be your biggest problem. There might be hail. So if you're driving on the road, there might be hail. There might be flooding embedded in these systems. There's obviously there's a tornado. There's also wind. There could be flying debris even in EF0. So don't take an EF0 lightly. If there's an EF0, there's also probably a severe thunderstorm warning. In addition to the tornado warning. But don't be scared. Don't think this is like gonna be crazy. It's not gonna be crazy. It's gonna be not too bad. But that's the shear. Decent shear. This is the supercell composites. This is like how favorable the environment is for supercells. Supercells are basically the parent of a tornado. You need a supercell in order to form a tornado. So this is important. Right now, it's decent. It kind of fires up around midnight. 12, 8. This is not how many supercells are going to form, but it's like a rating kind of. So this is decent. And it kind of goes away. But then similar to the other things like the Cape levels and the wind shear, kind of ebbs and flows. And it disappears. And then it reappears again. And similar to this is something to watch, I think, actually. This would be late night Sunday, so like 10 o'clock Sunday. The supercell composite and the Cape levels both look juicy for Sunday nights. That's something to watch. Maybe they'll upgrade this area in western New Mexico. I don't know if they will. I don't know if this is enough, but it is interesting. But the supercell composite, it looks kind of juicy, but it's nothing too crazy. This isn't nothing I'm seeing here indicates anything like an outbreak of tornadoes, but maybe we could have some isolated tornadoes. So yeah, supercell composite ebbs and flows. I'll go through it quickly. Kind of like the Capes and the wind shear, which is kind of interesting. But yeah, that's the supercell composite. Now you have the tornado parameter, which is like how favorable the environment is for tornadoes, straight up. And all the stuff that I showed before, like the Cape and the shear and the supercell, all go into that. There's other stuff on the model, but I feel like this is the most important stuff, which is why I'm showing it. The tornado parameter, we see it really peaking around, I believe this is 11 p.m., although don't quote me on that, might be 12 p.m. It's peaking too. We see tornado parameter above 2, which on the scale it's still like lower on the end, but it's decent, and it means that tornadoes can occur for sure. And it kind of, once again, it kind of disappears, ebbs and flows, but it comes back eventually. And this is something that's been interesting to me. It keeps showing at the end of the model run a potential for, I don't want to say not dangerous, more dangerous, but like there could be a slight risk tomorrow. I guess is what I'm trying to get at. I wouldn't be surprised looking at all this data with the tornado parameter and the joules per kilograms, the CAPE levels. Definitely wouldn't be surprised if there was a slight risk put out. So I'd be surprised, but I mean, it still wouldn't be anything too crazy. But I honestly wouldn't be surprised because this is looking interesting at the end of the model run. I announced SPC outlooks. So we have a marginal risk for everything pretty much. And the marginal risk all covers the same areas. We have tornado, wind, hail. There also is a rain risk. I'll get to that later. But we have it for portions of far northwestern Texas, far northwestern Oklahoma, throughout far eastern New Mexico, except this area of far southwestern New Mexico. We have it for, I don't even know how to describe it, like upper southwestern Texas, I would say. And we have a tailwind tornado outlook. However, the hail and tornado outlook actually don't extend to far southwestern Texas. Only the wind outlook does. So the tornado outlook and the hail outlook are far more north, and you have southern New Mexico isn't really included in that far southern New Mexico. That's something interesting to note. Day 2, it's similar, just a bit further south. Texas isn't included. Well, actually, the far, far, far western part of Texas isn't included. But it does go south. The tornado outlook is further south. I wouldn't be surprised if they were to upgrade this to a slight risk, especially for tornadoes. Actually, really for everything categorical. If they upgrade it for tornadoes, also upgrade it here. So I wouldn't be surprised if they did that, to be honest with you. Because some of the model that I'm looking at does look kind of juicy, but and maybe it isn't enough. Maybe the data isn't enough, but there definitely could be some tornadoes. Sunday night, I think, is actually going to be the higher risk night, if I had to guess. And by the prediction center, we do have slight risks for far northwestern Texas, far northwestern Oklahoma, western New Mexico, into portions of Colorado, and I believe Kansas. And that's the rain that I was talking about earlier, potential for widespread 2 to 4 inches, which could cause flooding in some areas. I know a lot of areas have had drought, but if your area has seen a lot of rain in this yellow area, that could be worse. Also, low-lying areas, like areas near creeks or rivers, those are always prone to flooding. So that's always a concern when you have repeated rounds of thunderstorms. There could be flash flooding too. So that's something to keep an eye on. Always be aware. So that ends the severe weather forecast. I might put out something tomorrow. We'll see, especially if they upgrade that thing to slight. But yeah, it's in the severe weather forecast. Now the short-term forecast. This is 3 hours out. This is our severe weather system, and you can see 1,002 millibar low. Heavy snow and rain for southwestern Canada with high pressure, which is weird, but whatever. Get this heavy snow, maybe dipping into far northern Idaho, far northern Montana. And we continue to see that precipitation. Finally, we get 1,003 millibar low moving onshore. So, potential for a lot of snow and rain, depending on exactly where you are in southwestern Canada. This low goes all the way up into Canada. The jet stream is ridging across the U.S. Warmer period across the U.S. likely next week. Maybe it's slightly colder in the Pacific Northwest. But overall, the U.S. should be warmer than normal next week. Beautiful weather for this time of year. But yeah, this low is going to go all the way into Canada. Potentially bring some snow to central Canada. I can't really see it. But you can imagine the rain snow line is probably about right here. So that's the systems going through Canada. Even this 1,002 millibar low. and a much warmer solution than the HRRR, which showed way more snow. There's a lot of rain, even in the higher elevations. So much warmer air in place. And which is interesting. I don't know. The NAM model seems to be dooming on the snow, but even if the HRR was correct, snow probably wouldn't accumulate below 5,000 feet. I would say maybe you could get some dustings at 4,000 feet. So you really have to be high up, and it won't accumulate in Denver or anything like that. By the way, so that's the NAM model, but it's pretty dry. There's not much to talk about. This looks like a tropical system, 1,005 millibar low, but you know, there's not. It's pretty dry. Pretty dry period for the lower 48. There's some severe weather, obviously, but really not too much precipitation to talk about, which is something that a ridge will do. You see this high pressure building, so that's going to keep the east dry for a while, and even the west is still dry. All right, so that's the precipitation. Now I have the temperature. It's colder in the west, and it's colder in the southeast. It's really warm across the central states and southern Canada along the Great Lakes and into the Ohio Valley. We get a bit of cooler air on Saturday to start off the day, and we get that warmth returning to the east. It's mostly above average. The northern is interesting. The northern tier of the country is way above average. Southern tier is still a bit below average. But then as we move into next week, we get almost all the country is above average, except for portions of far southwestern Arizona and the mountains of California. But in general, it's most above average in Minnesota, Wisconsin, Michigan. So the Rust Belt looks to be way above average, and that's interesting. That's an interesting pattern. If we go to the Climate Prediction Center, 6 to 10 day outlook, it's way above average, especially in the central states. 8 to 14, it's also above average, except in the Pacific Northwest, and it's near normal in the far west. So warmer than normal, especially for the east, looks to be the pattern.